So here are the notes for 4.3. This is when we're factoring when a equals 1. So we're going to factor quadratics when our a value is equal to 1. So just to let you know, some algebra review. You guys did this actually in Algebra 1, so a lot of this should be review. So here's some vocabulary words I want to go over because I will be using this quite a bit. The first one is what we call a monomial. So a monomial means one term. So we have some examples here. 3, well, that's only one term, so that's a monomial. If we have an x, that is also a monomial. Now here we have negative 4xy. Now you might be thinking, well, why is this a monomial? There's like 3 things. Well, the idea is like as long as it's being multiplied and there's no addition or subtraction in between, then that just counts as one term. So this whole thing is one term, so it is a monomial. Okay, binomials. So basically, you're going to be seeing those a lot whenever we factor. So binomials when there's 2 terms, and meaning that there's going to be an addition or subtraction sign in between our 2 terms. So like 2x plus 7 or x minus 3, those are binomials. And lastly, trinomials. Those are the ones that we're mainly going to factor. We can also factor binomials, and we'll kind of talk about those a little bit later on. With our trinomials, that means there are, once again, addition and subtraction signs in between each of the terms. That's what makes it a trinomial. So there's 3 of these. So that basically is what we're going to be factoring today and when we have a equals 1. Now, you might be thinking, well, what does a equal 1 mean? Well, if we kind of go back to the idea of quadratics, and we're going to go back to the idea of trinomials, the standard form is ax squared and then plus bx plus c. And then, of course, your addition signs could be subtraction, but this is kind of just the general form. So this is our general quadratic. A, B, and C are going to be numbers. So today, A is going to be 1. So like whenever we factor, you won't really see a number in front. And then B is going to be a number, and C is what we call the constant because there's no variable next to it. Now before we get into factoring, let's go back to the idea of the opposite, which we call the FOIL method, or you could say distributing or multiplying. Now, when we factor, this is what's going to look like, okay? Now, whenever we factor, we can actually check our answers. To check our answers, we can use the FOIL method. So remember, foiling is just taking basically the first set of parentheses, each term, and multiplying by each term in the second set of parentheses. So for this first example, x plus 4 times x plus 3. So the first thing is I'm going to do x times x. That gives me x squared. Then I'm going to do x times 3. That's going to give me 3x. Then I'm going to take my 4 and multiply by x. That gives me 4x. And then lastly, we're going to multiply the constants. Remember, constant means it's a number without a variable. So 4 times 3 gives me 12. Now, don't forget, when we use the FOIL method, we will have to simplify by combining like terms, and that is always going to be your 2 middle terms, okay? So when we combine this, we will get x squared plus 7x plus 12. So here, we went from 2 binomials, remember binomials means 2 terms, and when we FOILed or multiplied, we got into a trinomial, 3 terms, and it's a quadratic, and it's in our standard form, our ax squared plus bx plus c. So basically, this is a great way to check your answers. Okay, let's get into our factoring here. So let's go ahead and do the first example. So we're going to factor if possible. If it's not factorable, then we can say cannot factor or non-factorable, whatever you like to write. Okay, the first one is x squared plus 7x plus 10. This is a trinomial because there's 3 terms here. So now what we need to do is create 2 sets of binomials. What I mean 2 sets is that we're going to have 2 sets of parentheses, and each set's going to be 2 terms. Now, because our a value is 1, this is the nice easy ones because we can automatically just put x and x inside our parentheses. Now, in order to factor, we need to find two numbers that multiply to the last term or to our constant and add up to the middle term, okay? So, in order to do this, I'm going to find all the factors of 10. Now, you might be wondering, what do you mean factors? Well, when I'm talking about all the numbers that multiply to 10. So let's list those out. And I like to list them in numerical order. So we have 1 times 10, and then we have 2 times 5. Now, we need to pick the pair that will combine to get us a positive 7x. Well, 1 and 10 will never do that, but 2 and 5 will. So I'm going to go ahead and do a 2 and then a 5. Now, I want a positive 7, so the signs in front of my 2 and 5 are very imperative. Well, if I have a positive 2 and a positive 5, 2 plus 5 gives me 7. Now, this is where the FOIL method can come into hand. The FOIL method we can use to make sure this is the correct answer. So that's what I'm going to do. Now, you don't always have to do it. If you get very comfortable with factoring, you're like, I already know how to do it, then you don't really need to do this, but it's a great way just in case if it's a little bit harder to factor. Okay, I do x times x. I always do that. Then I do x times my 5. I get a plus 5x. Then I do 2 times x. That gives me 2x. And then 2 times 5 to give me 10. Okay, don't forget you got to combine your like terms. So that's going to be the 5x and 2x. So I get x squared plus 7x plus 10. And that is basically what I had at the very beginning. So that means I factored correctly, and x plus 2 times x plus 5 is my answer. Now, here's another thing. It really does not matter the order. So you could have had x plus 5 times x plus 2. That is all right. Okay, let's go ahead and try the next one. So we're going to do the same thing. So notice once again that our a value, or the number in front of the x squared, is 1. So that means we create our two sets of parentheses, and we do x and x. Now, we are trying to find two numbers that multiply to our constant, or the last term, and add up to the middle. That is very imperative to remember. In order to do that, I need to find all the factors, or the numbers that multiply to 20. I'm going to list them out numerically. So we got 1 and 20, 2 and 10, and then 4 and 5. So now we need to look at which pair, if we added or subtracted them, will get us a negative 9. Well, it looks like from our list, it has to be 4 and 5. Now, because we have a negative, that means I need to have a negative 4 and a negative 5. So negative 4 minus 5 gives me negative 9. It is very imperative that you have the correct addition or subtraction, or the signs correct there. Okay, and remember, if you're not sure, you can always multiply, and if you get the answer back that you had originally, then you factored it correctly. Now, also to let you know how I've been using the words factors, so the factors of 20, numbers that multiply? That's what these set of parentheses are called. These are also called factors, okay? I'll be using that term quite a bit whenever we factor. That's why we call it factoring. So these are factors because when I multiply, then I get this back here, okay? So remember that, especially when we get into the idea of using factoring to solve quadratic equations. Okay, so what I would like you to do is pause the video and go ahead and try x squared plus 13x plus 12 on your own. So go ahead and pause the video. Okay, let's go ahead and go over this problem here. So once again, I create my two sets of parentheses. I have x and x because my a value, or the number in front of my x squared, is 1. So I have 12. Let's list the factors. Remember, that means numbers that multiply to 12. So I have 1 and 12, 2 and 6, 3 and 4. Okay, now I want to use the pair that's going to add up to a positive 13. Well, 4 and 3, that one gives me 7. 6 plus 2 gives me 8. Ooh, but 12 plus 1 gives me 13. So I'm going to use 1 and 12. And since this is a positive 13, I have to use addition signs. So my factors are x plus 1 and x plus 12. And don't forget, you can switch that. So if you have the answer of x plus 12 and x plus 1, that works as well. The order of that does not matter. Okay, let's try more factoring here. So we have x squared minus 4x plus 4. Once again, we create our two sets of parentheses. The a value, or the number in front of our x squared, is 1, so I automatically put x in x. Now I find the factors of my last term, or the constant. So I have 1 times 4 and 2 times 2. Now I have to figure out which pair will add up to a negative 4. Well, 1 and 4 is definitely not going to do that, but we have 2 and 2, that'll work. So I have 2 and 2. Now we want to add up to a negative, so that means both of these have to be also negative. So negative 2 minus 2 gives us a negative 4. Now notice how my factors, so remember these are called factors, they are exactly the same. So you can write them like this, or there is another way to write your factors when they are exactly the same. The other way would be writing it as x minus 2, and don't forget your parentheses. So notice that I've always created parentheses, and we square it. Because that square is indicating, oh, there's 2 of the same factors. So this is another way of writing it if you have the same factors. Okay, let's go and get to our next one. Now, what we've been factoring have been trinomials, right? So this x squared minus 4x plus 4, that's 3 terms, that's a trinomial. These past 3 problems were trinomials. But now we're getting into some binomials that we can factor. Now, just as we've done before, because the a value is 1, I'm going to create 2 sets of parentheses. So I'm going to have 2 binomials as I've always had, and I'm going to have x and x. Now notice what is missing. We have our x squared, okay, and we have the constant, but we don't have the middle term. Really, the middle term is going to be 0x because we don't have it. So what we need to determine is what is a pair of numbers that will multiply to 4 and add up to a 0x. Well, let's determine all the numbers that multiply to 4. So we have 1 and 4 and 2 and 2. So if we added or subtracted, well, 1 and 4, that either will give us 5 or 3, so that doesn't work. But we have 2 and 2. If we added, that gave us 4. But if we subtracted, saying like 2 minus 2, right, that should give us 0. So it looks like 2 and 2 will be our numbers. Now, in order to get a 0x in our middle, well, we need to make sure that one is positive and the other one's negative. Because if we do 2 minus 2, that's going to give us our 0. Now, when we have these are what we call our difference of squares. So there is a certain name for these type of problems. So you might be wondering about how do I know when it's a difference of squares? Well, there are some conditions that need to be satisfied in order to be a difference of squares. First, that your quadratic is a binomial. So remember, that means it only has 2 terms, which this one did. It had the x squared and minus 4. Okay. Next thing, it has to be subtraction. Notice that we have a subtraction. That's what difference means. So difference also means subtraction. That's why, like, if we say, what's the difference between 0 and 2? We would say 2. Okay, here's another thing that could help you. So if you don't want to really think of, well, I need to add up to a 0x, here's another thing you can think of. So we talked about the difference, how that represents subtraction, but let's talk about squares. Let's go back to the idea of our perfect squares, right? So I'm going to go ahead and create a new page, and we're going to just talk about our differences, or the squares, perfect squares, okay? It's always good to know what our perfect squares are. And really, you do not need to memorize these, okay? All you need to know is how to generate, meaning like when we do 1 squared, that gives us 1. 2 squared gives us 4. Now you might be wondering, well, how do you get, when you do 2 squared to get 4? That is basically doing 2 times 2. Then you can think of 3 times 3. So let's go in order. So if we have 1 times 1, that gives us 1. If we have 2 times 2, that gives us 4. 3 times 3, that gives us 9. 4 times 4, that gives us 16. 5 times 5 gives us 25. If you notice, I am taking a number and multiplying by itself to give us a perfect square. That's how you can generate it. You can also plug it into your calculator if you want to. Okay, 6 times 6 gives us 36. 7 times 7 gives us 49. 8 times 8 gives us 64. 9 times 9 gives us 81. 10 times 10 gives us 100. 11 times 11 gives us 121. And then 12 times 12 gives us 144. So remember, perfect squares is generated by basically taking a number and multiplying by itself. So we go back to our problem. Notice that 4, our constant, that is a perfect square. But also the a value, the number in front of our x squared, which is 1, 1 is also a perfect squared. So basically your a and c values are going to be perfect squares. So those are the 3 conditions in which we have a difference of squares. Okay, let's try our next one here and see how we can factor it. Okay, we have x squared minus 36. Now notice, we have a binomial. There is subtraction. Now let's see if our a and c values are perfect square. Well, the a value, remember, which is the number in front of x squared, that is a 1, so that's a perfect square. And 36, if we go back to our list, that is also a perfect square. So this one is also a difference of squares here. So let's go ahead and factor this. Okay, so we create our 2 sets of parentheses. Now here's another easy way to factor difference of squares, okay? Well, basically, right, we need to make sure numbers multiply and add up to that 0x. Well, those numbers have to be exactly the same, right? So here, 2 and 2, they were exactly the same number, but different signs. Same thing, we need to have the exact same number, but our signs are going to be different. So if we think about it, we can think of, what is the square root of 36? That's going to give us the numbers that we're going to put into our set of parentheses. Well, the square root of 36 is going to be 6. So I place 6 and 6, which I know multiplies to 36. One has to be addition, one has to be subtraction. Because a positive 6 minus 6, that gives us our 0x, which would be in the middle. Okay, and then a 6 times a negative 6 gives us that negative 36. So that is our factorization of a difference of squares. So notice that your signs have to be different. One definitely has to be positive, one has to be negative. The order doesn't matter. And the number has to be exactly the same. Okay? Okay, let's go ahead. Let's continue on with factoring. So our next one is we're going back to trinomials. We have x squared plus 6x minus 12. Once again, since our a value is 1, I create my two sets of parentheses and I place x in both of them. I'm finding two numbers that multiply to my constant or last term and add up to the middle term. So let's think of numbers that multiply to 12. We have 1 and 12, 2 and 6, and 3 and 4. So let's see which pair adds up to a 6x. Well, 1 and 12 cannot do that. 2 and 6 definitely can't do that, and 3 and 4. So it looks like since none of these pairings work, this is what we would call non-factorable. So it is possible that you could have quadratics that you are not able to factor. So make sure you watch out for those, especially on the homework assignment. There we go. Okay, let's try our next one. So once again, we have a trinomial. Our a value, or the number in front of x squared, is 1. So I create my two sets of parentheses, and I do x and x. I go to my constant, figure out numbers that multiply it. We got 1 and 6, 2 and 3. Okay, so here we want to subtract, right? We want a minus 5, okay? Now, let's look at this one. Because we could do like negative 6 and positive 1, or we could do negative 2 and negative 3. So it seems like there's two possibilities here to factor x squared minus 5x plus. So let's see which one works, because actually only one pair of these will satisfy this trinomial. So let's try 1 and 6. 1 and 6. Because this is a negative 5, that means my larger number has to be negative, and my smaller number has to be positive. Now, I'm going to go ahead and FOIL this and see if this actually gives us our x squared minus 5x plus 6. So I do x times x, that gives me x squared. Then I do x times negative 6 to give me negative 6x. 1 times x to give me a plus x. And then 1 times negative 6 to give me negative 6. So once again, I add up my two middles. Because they're like terms, so I get x squared minus 5x minus 6. Now let's see if this is exactly the same as what we had up top. So we did have an x squared, we had a minus 5x, but this one shows a positive 6. But when I did 1 times negative 6, that gives me a minus 6. So really, this factorization of x plus 1, x minus 6 does not work. Okay, let's try a different one. Let's try it when we have negative 2 and negative 3. So we have x minus 2 and x minus 3. If you're thinking, well, how did she get minus 2, minus 3? Well, you can plug this into your calculator, or let's think about this. Negative 2 minus 3, that gives us negative 5, okay? So let's go ahead, let's multiply this out and see if we get the x squared minus 5x plus 6. So I do x times x to give me x squared. I do x times negative 3 to give me minus 3x. Then negative 2 times x to give me negative 2x. And then negative 2 times negative 3 gives me a positive 6. Definitely be careful on that multiplication. Remember, two negatives give me a positive. So now I combine my like terms, and then I get x squared minus 5x plus 6, which is exactly the same thing as we had in our original problem. So x minus 2 times x minus 3 is the correct factorization. So there is only one way to factor these quadratic expressions, okay? So if you think there are multiple ways, there actually is only one right answer. Now remember, you could mix these up, so you could have x minus 3, x minus 2. That is okay. It's because multiplication, order doesn't matter. So That is all right. Now this is what I would like to call our tricky problem, because a lot of people get this one wrong. So a lot want to do a +1 and -6, but when you FOIL it out, it does not give you the same answer back as our original problem. Okay, what I would like you to do is go ahead and pause the video and try this next problem, x squared minus 8x plus 6. Okay, let's go ahead and go over this. So notice that my a value is 1, so I'm going to create my two sets of parentheses, put x and x. Now I need to figure out the factors of my constant. Remember, constant means it's a number without a variable. Factors means numbers that multiply. Okay, I have 1 and 6 and 2 and 3. Now let's see which pairs add up to our middle term, which is going to be -8. Well, we do 1 and 6, that's not really going to get to it. It only gets to 7. And 2 and 3, that only get to 5. So this one seems like this is also non-factorable, because there are no pairs or numbers that multiply to 6 that'll add up to our middle term of -8. So as I said before, be careful. Really see if you are able to factor, because sometimes some of these problems are going to be non-factorable. Okay, we only have a few more problems left. So let's go ahead. We're going to do this one together, the x squared plus 7x plus 6. Once again, I create my two sets of parentheses. Since my a value is 1, I do x and x. Now I find the numbers that multiply to 6. I got 1 and 6, 2 and 3. And we got to look at which pair will add up to the 7. Well, this is nice. There'll be 1 and 6. And because we have a positive 7 to add up to, that means both my 6 and my 1 have to be positive, because 1 plus 6 gives me a positive 7. Okay, what I would like you to do now is go ahead and pause the video and go ahead and do the next two problems. Okay, let's go ahead and go over these two. So I create my two sets of parentheses, which I have two binomials. Remember, binomial means two terms, okay? Since my a value is 1, I use x and x. I find the factors of 12, so I have 1 and 12, 2 and 6, and 3 and 4. Well, the pair that'll add up to a 4 is going to be my 2 and 6. Now, because my 4 is positive, that means the bigger or larger number has to be positive, and my smaller is going to be negative, because 6 minus 2 gives me a 4. And then this will be my factorization. And remember, in these two sets of parentheses, these are what we call factors. Remember, factors are expressions, phrases, numbers that multiply. Okay, let's try our next one. Create two sets of parentheses, x and x. Find the numbers that multiply to 44. So this might be a little bit longer list maybe. So we got 1 and 44. We got 2 and 22. 3 doesn't work. We got 4 and 11. 5 doesn't work. 6, 7, 8, 9, 10. Okay, I guess this is it. Okay, now let's look at our list. Well, the pairing that'll add up to our -7, well, that has to be 4 and 11. So I have 4 and 11. Because our 7 is negative, that means the bigger number has to be negative, and our smaller number is going to be positive, because 4 minus 11, excuse me, that's going to give us -7. And remember, you can always multiply your two factors to see if you get the original problem. Okay, now we have our last three problems. Let's try this one together. So once again, I create my two sets of parentheses. I'll have two binomials. Binomials means two terms. So we'll have our factors. Remember, that means it's going to multiply. Okay, so 7, the only numbers that multiply to 7 are 1 and 7. So we kind of have to use that. Now notice that our middle term is negative 8. So in order to get that, both of these have to be negative. So negative 1 minus 7 gives me a negative 8. And when I multiply negative 1 times negative 7, that does give me a positive 7. So that works out. Okay, now go ahead and pause the video and do these last two problems. Okay, let's go ahead and go over these. So I create my two sets of parentheses. I got x and x. Let's find the factors of 10. I got 1 and 10, 2 and 5. The only pair that's going to add up to an 11 is 1 and 10. In order to add up to a positive 11, I got to have pluses on both of these. So 1 plus 10 gives me 11, and a positive 1 times a positive 10 does give me a positive 10. So that is our correct factorization. And then our last one, I create my two sets of parentheses. Let's list all the numbers multiplied to 18. We got 1 and 18, 2 and 9, 3 and 6, 4, 5. Okay, that's it. Okay, to do 3, it looks like it needs to be 3 and 6. Because my 3 is positive, that means the larger number needs to be positive, and my smaller is going to be negative, because 6 minus 3 will still give me 3. And when I do negative 3 times 6, that gives me negative 18. So this is the correct factorization. Okay, so don't forget to do the homework assignment for this lesson. If you have any questions, please contact me and let me know.